All right, we are starting section 7.5, our last section of chapter 7. Came quick. Friendly reminder that means tomorrow we will have a review day. Friday we will take a quiz over the second half of the chapter, 7.3.4.5. Monday, you don't have school, Martin Luther King Jr. Day. Tuesday, we will have a notebook quiz and a chapter review. So bring all your notes on Tuesday. Wednesday, 1 week from today, we will take our chapter test. So today we are going to use the triangle proportionality theorem and its converse. We'll just jump right on in. I will give you a couple minutes to write before we start talking about it. All right, in words, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So in this case, that line parallel to a side is TU. If TU is parallel to QS and it's touching the other sides of the triangle, then it divides the sides proportionally. So RT compared to TQ, it's dividing that side, is equal to RU compared to US, dividing the other side. I'm going to write this up here just so it's not split. RU, US. Take that one away. From the way this picture is drawn, it kind of looks like we have some congruent segments. That's not necessarily true. So if you were to draw this with TU being moved up a little bit, like up here, it might be a little more of an accurate representation. You don't have to. It could happen either way. I just don't want you to think that any of these are necessarily congruent to each other. They're just proportional. We are asked to find the value of x. How do we know that we have some parallel sides here? Yep, those little arrow triangles tell us that we've got parallel sides. They did flip it on its side so it doesn't look exactly like that diagram from our notes above, but that's fine. Same situation. I will preface this with saying that there are multiple correct ways to set up a proportion. I'm going to default to how the notes would have set it up. But with proportions, there are lots of equivalent ways to set it up that will still get you the correct answer. There are also just as many incorrect ways to set it up. So from the notes above, it said that it divides the sides proportionally. So I'm going to start at the bottom this time. So I'm starting here. What's one piece of that side? What's one part of that side? Somebody said it. X. X is one part of that side. What's the other part of it? 12. They belong in a ratio together. When we go to do the other side, we have to make sure we're being consistent, meaning that we started on the left by point P here when we started with X. So what do you think has to go in the top of our other ratio? 32. The 32 over 16. Okay, again, lots of correct ways that you can do this. Technically, if you really wanted to, you could simplify this ratio before you get started. You don't have to. You could just jump into cross multiplying. 16 would get multiplied by what when we cross multiply? X. And 12 would get multiplied by 32. If you have a calculator, that makes this pretty easy. Since I'm standing back here without one, I'm going to simplify before I multiply. How many times does 16 go into 32? Twice, which makes our denominator a 1. So I really just have to take 12 times 2, and I get x equals 24. Now, if you had a calculator and you multiplied it out and then divided, that's fine. You should have gotten the same thing. All they asked for was x, so we are done with that problem. Questions about it? Need more time on it? Continuing on. These examples are the same type of problem, so this top one will be 2. The bottom one will be 3. I'll give you a few minutes to get those diagrams down and try to set up your ratios, your proportions. Again, there are multiple correct ways to set it up, but there are also some incorrect ways. All right. Can anybody tell me the proportion they set up for number 2? Michelin? Good, that would be one correct way to set it up. Starting with this bottom side, 4 gets compared to 8, those two pieces, over equals x over 10. If you set it up differently, it still could be correct, as long as when you cross multiplied, you ended up with 8x equals 40 or 40 equals 8x. When we divide, we get x equals 5. Somebody else, can you tell me the proportion you set up for number 3?
Y over 20 equals 12 over 16.
Good, y over 20, starting with this side that's kind of more on the right. Y over 20 equals 12 over 16. Your proportion could have looked a little bit different, but as long as you ended up taking 16 times y equals 20 times 12, then it would still be correct. To solve this, we would have to divide both sides by 16. Again, if you have a calculator, great. If not, you can do some simplifying here. You could divide this one by 4. And then divide the 12 by 4. You should get y equals, I think 15, right?
Yeah.
15? Okay, again, if you've got a calculator and you just typed in 240 divided by 16, that should get you the same answer. Questions about triangle proportionality? Need more time on this slide. Need to ask about how we set these proportions up. Moving right along. Example 4 is a little bit different. I'll give you a moment to jot this down, and then we'll talk about it. So what's different about this problem is that we weren't given every little piece. On the last few problems, every little segment had been marked. This time we don't know the little segment, but we do know the whole side is 15. We know this little piece is y. So can anybody come up with an expression that would represent that little piece that we don't know? Any guesses? We want most of it. So we take the whole side, but we don't want that little y piece. If we don't want it, what operation do you think we would maybe use? Zasmin's got it. It's subtraction. So the whole side is how much? 15, but we want to take away how much? Y. So that little piece is represented by 15 minus y. So this little piece here is 15 minus y. Questions about how we built that expression? So now we won't really use the 15 when we make our proportion. So if we start with this left side, we would compare what to what?
Y to 15 minus 1.
Okay, y to 15 minus y. So we remember stick one ratio is one side. Equals, what would our, good, 10 over 20. If you would put the 15 minus y on top, that's fine, as long as the 20 also then went on top. Questions about this proportion? Okay, when we solve it, the 20 times y is easy, but when we cross multiply with the 10, what do we have to remember to do?
Distribute.
Very good. Distribute the 10. So we end up with 20y equals 150 minus 10y. To keep solving this, we need all our y's to be together. What should we do? Okay, I would agree with the adding 10y on both sides. That's not the only possible way of doing it, but I think it is the one that most algebra teachers would go for. After that, to get y alone, we should divide. What do we get for y? 5. Good. Questions on that last one before we do our converse? Need more time. Okay, I'll pause for a moment. No pictures, just words. The converse states that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So notice on the first set of examples above, we always had those little arrows showing us parallel lines. On the next set of examples, we will not have those little arrows, and we will have to decide if the lines are parallel based on whether or not the sides are proportionally divided. So as promised on these next examples, we do not have the little arrows saying that the sides are parallel. We are going to use the sides to decide if they are proportionally divided. So this will kind of be similar to when we were deciding if sides were proportional to decide if they're similar triangles. Same kind of idea. We're going to make ratios and see if they reduce to be equal. If our ratios end up being equal, then those sides are parallel. If not, they're not parallel. All right, so if we'd been doing these on the front side, what is one ratio we would have set up? 16 over 10 works. You could also do 10 over 16. So that's one ratio we're looking at. If we're using 16 over 10, what's the other ratio we should be looking at? Good. 12 over 9. We're not going to deal with number 6 yet. Those are two separate problems. So we're just in that first triangle right now. 16 over 10 reduces to be what? What is it?
8 over 5.
I would agree with 8 over 5. Divide both by 2.
Yes.
Okay. What about 12 over 9? Divide them both by 3, we get 4/3. So, are these proportionally divided? No, which means it doesn't matter what they look like in the picture. Those are not parallel sides. So you could say that BE not parallel to CD. You could just put a no if the question is BE parallel to CD? Okay, moving on to example 6. Give me one of my ratios I should be looking at.
24 over 32.
Okay. If I'm using 24 over 32, what should my other ratio be?
21 over 28.
Good. Make sure you're being consistent when you write your ratios. 24 over 32 simplifies to be...
6 over 8.
Okay, keep going.
3 over 4.
Good. Okay, that's as simple as that one gets. What about 21 over 28?
3 over 4.
It also ends up being 3 over 4. So, is BE parallel to CD? Yes. So you could put yes. You could write BE parallel CD. Just for fun, you could add the arrows in there. Questions, concerns about 5 and 6? Need more time. Moving on. All right, little bit of vocab. A mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. So, to make a picture, it doesn't have to be anything fancy. You could have triangle A, B, C. There are multiple mid-segments in a triangle. So if I say this is point M, how could I mark my diagram so that I know that that's a midpoint? What could I put in my diagram that would tell me that's definitely a midpoint? And good. Put the little congruent tick marks. That tells me that M is definitely a midpoint of that side. And then I can have a midpoint on another side. I'll put one down here. Again, I'll know that that's a midpoint if I know that AN is congruent to NC. So MN ends up being a mid-segment because it connects midpoints of two sides. There are other mid-segments that exist. So there could be a mid-segment from N over here to the midpoint of BC. There's another mid-segment from M to that same point. So there are multiple mid-segments inside every triangle. 3 of them to be exact. Questions about what a mid-segment is? Okay. Need more time on this one? We'll keep it moving. The mid-segment theorem states that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. So this is similar to the diagrams that we saw earlier, but it's a more specific situation. It's not just any segment parallel to the other side, it's the mid segment. So I'll again make my A, B, C. I'll put M over here again, N down here, making sure that I'm marking these to be congruent pieces so that I know that those are midpoints. And in this case, I will connect M and N to make a mid segment. So if M and N are midpoints, which I marked them to be, then we know a couple things. The first thing we know is that that mid segment, MN, is parallel to which other segment? BC. Okay, it's parallel to the one that it doesn't touch. That would be BC. The other thing we know from this theorem is that the length of MN is half as long as that same other segment BC. So if BC had a length of 10, MN would have a length of 5. If MN had a length of 4, what would BC have to be? 8. Make sure you're careful about which way you go. So MN is always the shorter one. So the other way of writing this would be to say that 2 times MN is equal to BC. All we did is multiply both sides of that equation by 2. So make sure you're being careful when you have questions about mid-segments, which way you're looking at it. Are you looking for the small one or are you looking for the big one? The small one should be your mid-segment. The big one should be part of the triangle. All right, on example 7, how do I know that I have a mid-segment there? So mid-segments connect midpoints. How do I know that I'm connecting midpoints? Because of the tick mark. So I know that these have to be midpoints. So that is a mid-segment. So what do we think X is?
84. Oh, wait, no. 24? Yeah.
We're getting closer.
21.
21. So this segment inside X should be equal to half of the side that it doesn't touch out here, the 42. So that would make X 21. All right, on number 8, again, these are midpoints. This time they didn't give us tick marks, but they labeled those pieces the same, 7 and 7, so that's a midpoint. 5 and 5, that's also a midpoint. Anybody think they know why? Jakeem? Oh, is it 3 or is it 12? I've heard both. It's 12. The big one is part of the triangle. Okay, the little one is the one on the inside. So in this case, 6 is equal to half of y. So if you times 2 on both sides, that gets rid of the half. And we get y equals 12. You don't necessarily have to show me that little equation. These ones, as long as you are being careful with if you're supposed to be making it bigger or smaller, you should be able to go straight to your answer. The one other thing I want to point out about these types of problems is that they could label these and tell you have a midpoint. Let's just label this side A, B, C real quick. They could ask you, what is the length of BC? What would you say? Based on how I just labeled it. 8. They could also ask you for the length of AC. What would that be? 16. So just because our main focus has been the mid segment, that doesn't mean they won't ask you questions about the other sides. Okay, but that's old stuff from last semester, so it should be familiar.